Right now, as you are watching this, meteorologists tracking the upper atmosphere across the Northern Hemisphere are observing something that the calendar says should not be happening for another 6 to 8 weeks. The strong seasonal transition that normally reorganizes the entire weather machinery of the northern mid-latitudes in mid to late autumn, the strengthening of the subtropical jet, the development of a coherent polar, cold pool, the emergence of the deep upper-level troughs that steer winter storm tracks is showing measurable, model-confirmed signs of setting up in the middle of August. On August 18, 2026, the National Centres for Environmental Prediction, the European Centre for Medium-Range Weather Forecasts, and the Canadian Meteorological Centre all issued their extended outlooks, the twice-monthly, 6-week look at how the atmosphere is projected to evolve, and all three converged on the same unusual scenario. A significant early strengthening of the Northern Hemisphere polar cold pool is projected over the next 21 to 28 days. The Arctic Oscillation Index is projected to shift toward a strongly positive state ahead of its normal October transition. The Pacific and Atlantic jet streams are projected to consolidate into their winter configurations weeks ahead of schedule. And the meridional temperature gradient, minus the north to south temperature difference that drives every large-scale weather system on Earth, is projected to sharpen dramatically through the first week of September. In plain language, the machinery that produces autumn's first severe cold outbreaks, its first major windstorms, and its first snowstorms across the northern tier of the continent is spinning up now in mid-August, in a way that has almost no analog in the modern satellite era. And the reason the phrase faster than anyone expected fits this specific pattern is not just that it is early, it is that the speed of the transition has already caught the operational forecasting community by surprise. 2 weeks ago, these signals were not present. 1 week ago, they were marginal. Today, they are the strongest signal in the seasonal outlook window across 3 independent modeling systems. Today, we break down exactly what is happening in the upper atmosphere and why the timing of the seasonal transition matters enormously for the weather to ordinary people experience, why an early hemisphere-wide pattern change has cascading consequences that reach far beyond the calendar of when the first snow falls, the specific weather categories that this early setup makes more likely across North America and Europe in the coming weeks, and the 2 weather seasons in modern memory that show what an unusually early or late pattern setup actually looks like when it arrives on the ground. No guessing, no dramatizing, just the meteorology, the record, and the real stakes. Drop a comment right now. Where in the world are you watching from? Because the specific consequences of this early pattern setup depend entirely on your latitude and longitude, and I want the comment section to become a map of first-hand observations as this pattern lands. Have you noticed anything unusual about your local weather in August? The mornings colder than they should be, storm patterns arriving that feel out of season, jet stream signatures across your sky that look more autumnal than summery. Tell me your city and what you have seen, because the surface signature of an upper atmosphere pattern change often shows up in ordinary people's observations before it fully registers in the news. Subscribe right now if you want every extended outlook, every pattern development, and every major weather-driven event covered as this transition unfolds through the coming weeks. Completely free. A thumbs up helps this reach the people whose next month is about to be shaped by exactly what this video describes. Let us go for 6,000 likes. Now, let us start with what the seasonal transition actually is. Because most viewers have never had it explained, every autumn, the Northern Hemisphere undergoes one of the most important atmospheric reorganizations of the year. Through the summer, the North Pole receives 24 hours of sunlight, and the polar atmosphere is comparatively warm. The temperature difference between the tropics and the pole is at its annual minimum, and the jet stream that separates cold air from warm air is at its weakest and its most northern position. As the Arctic loses daylight through late summer and into autumn, the polar atmosphere cools rapidly. The north-south temperature difference strengthens, and the jet stream intensifies and pushes southward. This is the seasonal transition. It is what turns July's stable warm weather patterns into October and November's parade of storms, cold fronts, and lower pressure systems that drive the mid-latitude winter climate. The timing of this transition is not fixed. In some years it happens on schedule, a gradual strengthening through September that reaches its full expression by early November. In some years it happens late, a prolonged warm autumn with a weak jet stream that keeps storm activity muted well into December. And in some years, it happens early, a rapid strengthening in late August or early September that pulls the weather machinery of autumn into what should still be summer, delivering the year's first severe cold outbreaks, its first significant snows, and its first major mid-latitude windstorms weeks ahead of the historical average. What the August 18th outlooks are converging on is the third scenario with unusual intensity. The specific indicators are technical, but interpretable. The 500 millibar geopotential height pattern, the atmospheric control map that meteorologists use to track large-scale flow, is projected to develop deep troughs over eastern North America and northwestern Europe by mid-September that would be entirely normal in late October. The polar cap temperature, the average temperature of the Arctic at various altitudes, is projected to decline through the next 3 weeks at a rate normally observed in the last week of September and first week of October. And the Arctic Oscillation Index, which measures the strength of the westerly circulation around the pole, is projected to reach fully positive values ahead of any autumn in the recent observational record. These are not predictions of specific storms. They are the atmospheric preconditions from which specific storms emerge. When the seasonal machinery sets up early, the events it produces show up early. That is what the models are converging on. And the reason multiple independent forecasting systems reaching the same conclusion at the same time is significant is that these systems disagree far more often than they agree at the dactyl, extended outlook timescale. When they agree because the atmospheric signal is unusually strong. Now, what does this actually mean in terms of weather that regular people will experience? For the northern tier of the United States and the southern Canadian provinces, an early setup like this typically produces the first significant severe cold outbreak weeks before communities are used to it. Not a February-style extreme, but a genuine early winter arrival, sub-freezing, overnight temperatures reaching well south of the Canadian border by early September, hard frosts, damaging late-season agricultural operations, and the first significant snowfall arriving in the Mountain West and the Northern Plains weeks before the historical norm. For agriculture, this class of pattern is particularly consequential because September is the peak harvest month for major grain and specialty crops across the Midwest and Great Plains. An unseasonable frost arriving before harvest completion causes losses that no crop insurance product fully covers. For the Great Lakes region in New England, an early strengthening of the jet stream tends to shift the storm track southward from its late summer position, delivering more frequent and stronger rain events, and eventually the first snows. Early season lake effect snow is a specific hazard that requires exposed water temperatures still warm from summer, combined with cold air masses moving over them. That combination arriving in September rather than November produces particularly intense lake effect events because the water-air temperature contrast is at its maximum. For the Atlantic Hurricane Basin, this is the most consequential and least discussed consequence of an early autumn pattern setup. The peak Atlantic hurricane season runs from mid-August through October, and hurricane behavior is enormously sensitive to the position and strength of the jet stream. A jet stream that has already dropped south into its autumn configuration can rapidly reshape hurricane tracks and intensities. Storms that would have curved harmlessly out to sea under a summer jet stream can instead get captured by the strengthening westerlies and driven directly toward the U.S. East Coast or into rapid extratropical transition, becoming the hybrid ocean windstorms responsible for some of the most damaging historical events. Sandy in October 2012 was such an event. Its impact on New York and New Jersey was massively amplified by exactly this class of pattern configuration. For Europe, an early strengthening of the Atlantic jet stream drives more frequent and stronger low-pressure systems across the North Atlantic toward the British Isles and continental Europe. The autumn windstorm season across the UK, Ireland, France, and the Low Countries traditionally begins in late September. An August-driven pattern setup can advance that season by weeks, producing significant windstorms and heavy rain events across northern Europe well before infrastructure and agriculture are configured for them. For the Mediterranean, an early jet stream setup often correlates with the arrival of major metacane events, the Medicane tropical-like cyclones that form in autumn over the warm central Mediterranean and produce catastrophic flooding along the Greek, Italian, and Turkish coasts. Every one of these consequences is a knowable downstream effect of the atmospheric configuration the models are now converging on. None of them is a specific prediction. All of them are elevated in probability. Now let us look at what unusually early and unusually late seasonal transitions have actually produced when they arrived on the ground. because history offers two very clear examples that show what this class of pattern shift means at the human scale. In the autumn of 2011, the Northern Hemisphere jet stream underwent an unusually early and dramatic reorganization in late September. By October 29, 2011, a strong nor'easter formed off the mid-Atlantic coast, drew moisture northward, and delivered what was called the Halloween Snowstorm to the northeastern United States. Snowfall totals reached 80 centimeters in parts of interior New England. New York City set October snowfall records. Trees across the region, still fully leafed out in their early autumn foliage, were destroyed by the wet, heavy snow, and the resulting damage to overhead power lines produced multi-day outages affecting over 3 million customers. 22 people died across the region from the storm and its cascading impacts. The autumn of 2011 had arrived with the jet stream configuration of December, and a storm system that would have been ordinary in January was instead catastrophic in October, because nobody was ready for it. It's starry. Now compare that to the autumn of 2015. The 2015 autumn was one of the warmest and most jet stream week on record for the eastern United States. Through October and much of November, the seasonal transition simply did not happen with normal timing. The mid-latitude storm track stayed weak. The first significant cold outbreak did not arrive until mid-December. Autumn foliage extended weeks beyond normal. Agricultural harvest timing was leisurely, and Northern Hemisphere natural gas storage inventories built to historically comfortable levels because heating demand did not materialize on schedule. The 2015 late-arriving autumn was, in most respects, a benign anomaly, the opposite direction from 2011, but demonstrating the same principle. When the seasonal machinery sets up on a timeline different from the calendar, the human consequences follow the machinery, not the calendar. The August 18, 2026 signals point to a 2011 style scenario, potentially more extreme. Northeast snowfall in October is one class of consequence. A hurricane season peak arriving into a jet stream configuration that captures and intensifies systems is another. Agricultural losses from early frost is a third. European windstorm season starting weeks early is a fourth. None of these are certain. All of them are meaningfully more likely than they would be against a normal timing seasonal transition. And the reason to communicate the pattern now, in mid-August, is precisely that a 3 to 6 week lead time is what allows utilities, agricultural operations, emergency managers, and individuals to prepare, and by the time the specific storms arrive, the preparation window is closed. Let us be direct about the practical message, because information without action is just anxiety. If you are in the northern tier of the United States, or in Canada, this is the year to complete winter preparation earlier than usual. Home heating system service, winterization of exposed plumbing, snow tires, roof load capacity assessments, generators fueled and serviced. Every one of those items has a normal completion window that assumes weather begins to shift in October. If it shifts in September, that window closes early. Do the work now. The 2015 autumn was one of the warmest and most jet stream week on record for the eastern United States. Through October and much of November, the seasonal transition simply did not happen with normal timing. The mid-latitude storm track stayed weak. The first significant cold outbreak did not arrive until mid-December. Autumn foliage extended weeks beyond normal. Agricultural harvest timing was leisurely. And Northern Hemisphere natural gas storage inventories built to historically comfortable levels because heating demand did not materialize on schedule. The 2015 late-arriving autumn was, in most respects, a benign anomaly, the opposite direction from 2011, but demonstrating the same principle. When the seasonal machinery sets up on a timeline different from a calendar, the human consequences follow the machinery, not the calendar. The August 18, 2026 signals point to a 2011 style scenario, potentially more extreme. Northeast snowfall in October is one class of consequence. A hurricane season peak arriving into a jet stream configuration that captures and intensifies systems is another. Agricultural losses from early frost is a third. European windstorm season starting weeks early is a fourth. None of these are certain. All of them are meaningfully more likely than they would be against a normal timing seasonal transition. And the reason to communicate the pattern now, in mid-August, is precisely that a 3 to 6 week lead time is what allows utilities, agricultural operations, emergency managers, and individuals to prepare, and by the time the specific storms arrive, the preparation window is closed. Let us be direct about the practical message, because information without action is just anxiety. If you are in the northern tier of the United States or in Canada, this is the year to complete winter preparation earlier than usual. Home heating system service, winterization of exposed plumbing, snow tires, roof load capacity assessments, generators fueled and serviced. Every one of those items has a normal completion window that assumes weather begins to shift in October. If it shifts in September, that window closes early. Do the work now. If you are in Atlantic hurricane country, particularly the Northeast U.S. corridor from the Carolinas to New England, an early jet stream setup dramatically raises the probability of a hurricane recurving into your coast rather than out to sea. Do not draw down your hurricane readiness in September. The specific configuration of pattern the models are converging on is the Sandy configuration. If you are in the agricultural sector, particularly grain, produce, and orchard operations across the Midwest, Great Plains, and Mid-Atlantic, the early frost risk this year is elevated. Frost dates historically used for harvest planning should not be treated as reliable this season. If your operation can accelerate harvest of frost-sensitive crops, this is the year to do it. If you're in Europe or the Mediterranean, the autumn windstorm and heavy rain season may arrive weeks early. Coastal defense readiness, drainage system maintenance, and emergency management staffing that traditionally activates in late September should be activated in early September this year. For everyone, pay attention to the extended forecasts through the next 4 weeks. If the pattern verifies as the models are projecting, the events it produces will begin arriving in the first week of September and continue building through the month. Being aware of what class of events to expect is what allows early action instead of reactive response. Final thought. The atmospheric machinery that produces autumn's weather does not run on a calendar. It runs on physics, the amount of sunlight the Arctic is receiving, the temperature difference between the tropics and the pole, the interaction of ocean and atmosphere at the boundaries where the two exchange heat. When those physics align to trigger the seasonal transition on schedule, the world experiences a normal autumn. When they align early, the world experiences autumn's events in what should still be summer. And when 3 independent global forecasting systems all converge on the early scenario in mid-August, but means the physics has moved ahead of what the calendar and the news cycle and the assumptions of ordinary preparation are ready for. The pattern the models are showing is not new in category. Early seasonal transitions have happened before. What is different this year is the speed of the setup, the intensity of the multi-model agreement, and the compression of the lead time between when the signal became clear and when its consequences will begin to be felt on the ground. 3 weeks, maybe 4. That is the window between the outlook that dropped this week and the first storms and cold snaps it is projecting. If you use that window, the pattern is a warning that leads to preparation. If you dismiss it as too abstract to matter, it becomes a series of surprises that arrive in early September and continue building through October, surprises that could have been anticipated because the atmosphere told us in mid-August exactly what it was doing. The forecast is out. The lead time is real. What the next month looks like now depends on what happens in the weeks between this outlook and the events it is projecting. We will track every extended outlook update, every pattern development, and every major weather event as this transition unfolds. Subscribe so you do not miss it. And leave that comment. Your city, your latitude, and what your local weather has looked like this week, because ground truth from around the hemisphere is the map this story deserves. 6,000 likes. Let us go.